ఎలా ఉన్నారు? సో అందరూ బాగున్నారా? సో ఏటీఎల్ వే టు ఇన్నోవేషన్ అలాగే నిర్మాణ థింకింగ్ కి స్వాగతం చూస్తున్నారు. సో దీపావళి అందరూ లాస్ట్ తో బాగా సెలబ్రేట్ చేసుకున్నారు అనుకుంటా. సో ఈ రోజు మళ్ళీ మీ కొత్త టాపిక్ తో మీ మీదకు రావడం జరిగింది. అదే వర్కింగ్ వర్కింగ్ అండ్ అడ్వాన్స్ సైక్లోమీటర్ విత్ లేజర్ ప్రాజెక్ట్. లేజర్ తో ప్రొజెక్షన్ చేసి దాని హైట్ ఎంత అన్నది మనము కనుక్కుందాం. సో ఇంకేం లేదెందుకు, చూద్దామా ఎలా చేద్దాం, ఏంటి, ఎలా వర్కింగ్ ప్రిన్సిపల్ ఏంటి అన్నది చూద్దాం. సో అందుకన్నా ముందు మన ఆన్లైన్ అటెండెన్స్ అన్నది స్కాన్ చేసి ఫిల్ చేయండి.
Apply the trigonometrical identities. We have made a product called as Clinometer. So previously we would have seen another similar topic which was used to identify for a limited height of a object. So using this product we can identify the height of even a building. Only thing is that if you can do this experiment in evening times, when there is no much sunlight, you can clearly see the laser projections over the walls. Okay, so the components that we have used are we have cut few foam boards and we have made this model. So inside we have also fixed a measuring tape, so of 3 meter. You can also use 5 meter or 15 meter. It's up to your choice depending on how long the adjacent you would be taking to. And we have used 2 laser lights and 2 protractors. One of the protractor is fixed onto the surface, and also this laser light is also fixed. So this fixed laser light will be giving you the projection towards the adjacent side of the triangle. Okay, so onto that projection of light we'll be measuring the distance of adjacent side of the triangle. On the other side of the device we have this movable protractor which is of 360 degree. So this projection will show us, we can project this laser light towards the height of any wall, buildings or gates. So today we'll be using this clinometer device to measure the height of a gate. Okay, so in order to find the height, we'll be using 2 methods. So first method is using the height formula, that's nothing but h is equal to small h into tan alpha by tan beta plus 1. Okay, and the second method is using the basic trigonometrical fundamentals like sin theta is equal to opposite by hypotenuse, cos theta is equal to adjacent by hypotenuse, and tan theta is equal to opposite by adjacent. So now let's see how we can measure the height using the first method. So now let's see how to use the height formula to determine the height of the gate. Okay, so you might wonder what are these triangles over here. Okay, so this is nothing but I have written over here. So this is the line of laser light projection from clinometer to the top point of the object. Okay, and this line, so this line will be the line of projection of laser light towards the bottom point of the object. This is the bottom point of the object, this is the top point of the object. Okay, and this center line, so this center line is nothing but it is the 0 degree angle. Okay, so at 0 degree I will be projecting the laser beam, so that beam will be projected on the surface of the object. Okay, so if this is the object, okay, so if this is the object, if I project the laser beam at 0 degree, so that will be projected onto the surface of that object. All right, and at the point of projection, so if this is the
if this is the laser beam pointer, and if the projector is being pointed over here, so from that point to the bottom point of the object, we have to check what's the distance. Okay, so that distance will be the height, small h. Okay, so the overall height of the object will be the capital H. So that's what is written in the formula. So capital H is equal to small h into tan theta 1 divided by tan theta 2 plus 1. Okay, so you might wonder what is theta 1 and theta 2. So we got to know what is capital H and small h, right? Now let's see what is theta 1 and theta 2. So theta 1 is nothing but it is the angle at which the projection of laser light is made. Okay, at what angle the projection is being made to point at the topmost point of the object. Okay, so that is the theta 1. So theta 2 is also similar, but the laser pointer is now pointed on the bottom portion of the object. So when that projection is made, so there will be certain angle, right, from 0 to, so there will be certain angle, so that angle will be theta 2. Okay, so now we got to know what is capital H, what is small h, what is theta 1 and theta 2. Now let's do the experiment. Okay, we'll gather all this data, and then we'll put them in this formula, and we'll calculate the overall height of the object. Okay, so once we calculate that, we'll measure the actual height using a measuring tape, and we'll verify whether this height formula is actually working or not. So if it's working, we'll calculate the percentage error of the method. Okay,
So now let's find out the unknown factors. So to find the unknown factor H, I'll project the laser beam towards the gate, and I'll then measure the distance of projection from the base of the gate. So I'll turn on the laser projection, and I'll check at what distance the projection is being made. Okay, so you can see this is the bottom of the gate, and the projection is at a distance of around 67, yeah, around 67 centimeter. Okay, so this will be our small h. So now let's find the angle of projection that's at an angle alpha. That's nothing but the projection of laser beam from 0 degree to the top of the gate. Okay, so now both the laser beam projections are aligned straight. Now I'll move the hypotenuse projection towards the top of the gate. So by doing this, we can find out at what angle the projection is being made. So you can see the laser beam being projected at the top of the gate, right? Now let's check at what angle this projection is being made. So the projection is made at an angle of 52 degree. Okay, so this will be our theta 1 or alpha angle. So now let's check the angle of projection at beta. Okay, so here you can see the laser beam being projected at the bottom of the gate. Now let's check at what angle the projection is being made. So angle of projection is at 341 degree. Okay, So 341 is nothing but 360 minus 341. That's something around 19 degrees. So 19 degree is the laser projection at beta angle. Beta angle is nothing but theta 2. Now let's do the calculation and find the height of the gate. So now using method 1, that is using the height formula, we'll be determining the height of the gate. Okay. So for that, let's draw an virtual diagram of how we would have represented it using a right angle triangle. Okay. So for that, I'll draw a wall. So this will be the wall. So in wall you could have seen some elevation, right? Or gate. Yeah. This will be the gate. So there will be certain elevation here, right? So we shouldn't consider this part. So I also draw this, and this will be our ground. So this is our ground, and this complete part is the gate. Okay, so this is the gate, and so there was a table over here, right? So we had placed the clinometer over the table. So let's draw a virtual table over here. So this is table, and over the table we had placed the clinometer. Okay. So this is the clinometer, the advanced one. Okay. So we had to find the height of the gate, right? So not to find the height. So what I'll do is that I'll project a laser towards the gate. Okay. This is at an angle of 0 degree. So at an angle of 0 degree, I'll be projecting a laser beam. Okay. And then what I did, I measured this certain height. Right. So what did I say? So this height was the small h of the formula. Okay. So this was the h, small h. So small h was nothing but 67 centimeter. Okay. Now we'll find out the alpha and beta value, or you can call it as theta 1 and theta 2. Okay. So then I projected the laser beam towards the top of the gate from center. And then I got some angle over here. So what was the angle? So the angle was theta 1 is equal to 52 degree. And the second angle of projection was at an angle of theta 2 is equal to 19 degree. So this was laser beam 1. And this line is considered as the laser beam 2. Okay. Theta 1 is equal to 52 degrees. Laser beam towards the will measure the exact height of the gate and find how accurate this formula was. Okay. So h is nothing but 67 centimeter into tan theta 1. Theta 1 is nothing but 52 degree, and tan theta 2, that's 19 degree plus 1. So now we'll put this in calculator and find the height. Okay. So to find the tan value, you can have one method to find, that is using the normal calculator in your phones, or you can use the scientific calculators. And also there is one more option. You can download from Google Play Store, or you can just go to Google and search uh, the scientific calculator. Okay. So now let's see what's the value of tan 52. Okay. So 67 into tan 52. So tan 52 is nothing but 1.279. So if we round it off, it will be 1.28 divided by tan 19. So tan 52 was 1.28 and tan 19. So tan 19 is equal to 0.344. 0.344 plus 1. Okay. Is equal to 67 into 1.28 divided by 0.344. So that's nothing but 3.72 plus 1. So when we add this up, 67 into 4.72, right? So the total height will be 67 into 4.72. So that's nothing but 316.24 centimeter. Because we considered this height in centimeter, right? That's why we have to use the same unit. If you consider this as meter, then this will be, you will be getting the value in meter. So this was a theoretical method to find the height of the gate. Now let's do method 2, that's using normal trigonometrical functions like sine, tan, cos theta and all. And then we'll check practically what was the actual height of the gate, so that we can verify and do the error percentage calculation to determine the accuracy.
Okay. So in previous method, we saw how to use the height formula to find the height of this object, right? So this is a different method. So now let's see how to use the basic trigonometric functions to find the height of the object. Okay, so basic trigonometric functions are nothing but the sine theta, cos theta and tan theta, right? And also I think by now you are much more familiar with this diagram, right? So so you know that this is a triangle, right? So what we have done now, we have divided this one triangle into two halves. Okay, so two halves of two right angle triangles. So this is right angle triangle 1 and this will be our right angle triangle 2, right? But we all know what each line represents. So this line is represented as the height of the object or height of the gate. I'm mentioning gate because we have measured the height of the gate, right? Okay, so it can be a wall or a building or even a height of your school, anything. So whatever object you are measuring, whatever height of the object you are measuring, you can consider that. Okay, so commonly we can call it as an object. Okay, so this line is this laser light projection towards the top of the object. So this is the top of the object, right? And this is the bottom of the object. So when the laser light is projected from here to bottom, that will be the projection towards the bottom of the object. When the laser light is projected on top, that will be the projection towards the top of the object, right? So in a right angle triangle, you know there are three sides. So one side is the hypotenuse, the other side is the opposite. Opposite side is found out by the angle uh, theta. So if it theta angle is mentioned over here, the right opposite thing of that angle is the opposite side of the triangle, and the base is the adjacent. You can call it as base or adjacent. Okay. So similarly, in this triangle also we have three sides: hypotenuse, opposite, and the base. The only common thing in this both triangles are the adjacent sides. Okay, so adjacent side remains constant. Okay, so what we will be doing is that, so we will be first measuring the distance from clinometer to the wall using a measuring tape. Okay, so using measuring tape, I'll find what's the distance from clinometer center to the uh, uh, gate or the object. So first I will be finding that measurement, and then what I will do is that, placing the clinometer at the same point, I will be projecting the laser beam. So first laser projection will be made towards the top of the object. Okay, so similarly I will project the laser beam towards the bottom of the object, and I will note down the theta 2 value. Okay, then uh, I'll consider this as case 1, and I'll consider this as case 2. So in case 1 we will be finding the first angle, and in case 2 we will be finding the second angle. So then I will do two different calculations to find each triangle's individual opposite sides measurement. Okay, so once both the opposite sides are determined, I'll add them both. So when I add h1 and h2, I'll get the overall height of the object, right? So if this is h1 and this is h2, then if I add these two, I should get the overall height. Am I right? So to find this opposite side, we will be using these three formulas. Okay, but we won't be using all the three formulas. You have to identify which formula is to be used. Okay, by considering what are the data that are available for you to consider which of the formula you will be using. Okay, so how you will find which is the right formula to be used? You have to find out what are the data that are available in your hand to find the find the opposite side, right? So in sin theta you have three factors, that is theta value, opposite, and hypotenuse. So you cannot measure this hypotenuse value, you don't know the opposite value, so you cannot use sine formula. Similarly in cos you know the adjacent value, but you don't know the hypotenuse value, and you know the theta value. So by finding adjacent, there is no use in using that formula to find opposite, right? So there is no opposite factor itself in this cos formula, so we cannot use this one. So now let's see whether we can use tan theta formula. So in tan theta we have opposite by adjacent. So we know the adjacent value, we know theta value, and we have to find the opposite side. So we'll be using tan theta formula. This is how we have to consider which formula is to be used uh, when the certain data have been provided. Okay, so you know what is h1, right? What is h2? Theta 1 and theta 2. Okay, h1 is the height at which the clinometer is placed from the bottom of the object. From bottom of the object, at what distance the clinometer has been placed. h2 is the height at which the clinometer is placed from the top of the object. From top of the object, at what height the clinometer has been placed. So theta 1 is the angle of elevation, and theta 2 is the angle of depreciation. Okay, and keep a note, the adjacent in this method is measured using a measuring tape. So we'll be using measuring tape to measure this distance. Okay, now let's move on to the practical part, and check how we can use that clinometer device to determine the height of the gate. Okay, so and one more disadvantage in this method is that you cannot uh, use this method when the object is too far. Okay, so if it is within 15 meters, maybe you can use a 15-meter measuring tape and measure the distance, but that's not the case when it is too far. Okay, so that will be your limitation in this method. Okay, now what we will be doing is that we'll use, so method 1 and method 2 we will compare and check which is more accurate and efficient. Okay, now to the method 2 experiment.
So we took the required data from that case 1 and case 2 study. So from the experiment, we got to know that in case 1, angle theta was equal to 32 degree and adjacent was 6 for both case 1 and case 2. So here the theta 2 was equal to 360 minus 341 degree. Okay, so theta 2 is equal to 19 degree. Okay, so the adjacent was 186 centimeter plus, you can see this 75 centimeter, right? That is from the center of the protractor to the reading which we took from the meter tape. So we have to consider even that distance. So considering that distance from the protractor, so the adjacent side was 186 plus 135, 7.5 centimeter is nothing but 190, 93.5 centimeter. Okay. So now let's do a virtual diagram of what we actually did. Okay, so let's consider this as the height of the gate. So this will be considered as height of the gate. Okay, so this will be our ground. So we had placed a table over here. So on top of the table, we had placed the clinometer. So then from clinometer, we have projected a laser light towards the wall, which was parallel to the ground. So the distance of that line projection of that line was using a meter. We got to know that it was 186 centimeter. So this is the adjacent. Okay, adjacent, or you can call it as base. 186 plus we had to consider this distance also, which was nothing but 7.5 centimeter. Okay. So considering both the distance, we get the adjacent value as 193.5 centimeters. Okay. This will be our base value. Now we have projected a light from exact center at an angle theta 1 to find the height 1 of the wall. Okay. So this will be our height 1 and this will be our height 2. This is, height 1 is nothing but opposite 1 and opposite 2. Okay. So the projection of laser light towards the height of the gate, it was at an angle of theta 1 is nothing but 52 degree. Okay. Now let's see the projection angle of theta 2 to find the height 2 of the gate. Okay, so this will be theta 2 at an angle 19 degree. Okay, so now we know this is the opposite, we know this is the adjacent and this is the hypotenuse 1. Okay, so this is the laser light projection 1, projection 2 and projection 3. So we know that to find the complete height of the wall, that is nothing but h, we have to add h1 and h2, right? To find the height of the gate, what we have to find is that h is equal to h1 plus h2. Okay, so to find h1 and h2, what we can do is that we can use the trigonometrical identities or trigonometrical functions, the basic functions, which are the sine theta, cos theta and tan theta, because we know the adjacent, opposite and hypotenuse, and also we know the theta value, so we can find this. You have to choose the right function to determine the height of the gate. Okay, so considering the trigonometric identity, sin theta is equal to opposite by hypotenuse, cos theta is equal to adjacent by hypotenuse, and tan theta is equal to opposite by adjacent. So we have three formulas, right? So among these three, which one will you choose? So that's the other part of the calculation. Okay. So if we consider sin theta, if we want to use sin theta, let's see what are the datas which we require to find the opposite. Okay. So let's see. We know theta 1. We know theta 1, we know theta 2. Right. Okay. We can consider sin theta. We have to find opposite. Right. So opposite, we don't know. We have to find hypotenuse. We even don't know hypotenuse. So to find one of them, we have to at least know the data of we have to know at least two data, maybe theta or hypotenuse. Okay. So in this we don't know both opposite as well as hypotenuse. So we cannot consider this formula, and we can check with the second one. So if we see in this formula, we don't even have this opposite in it. So our actual objective is to find the opposite height of the perpendicular height of the gate, right? So as we don't have opposite in this, we cannot use cos theta also. So we won't be using cos theta, we won't be using sin theta. Now let's see whether we can use tan theta formula. Okay, we know the theta value, we don't know the opposite value, and we know the adjacent value. So we can consider to use the tan theta formula in order to identify the height of the gate. Now let's see how to calculate and determine the height of the gate. Okay, considering the case 1. Considering the case 1, we know that theta 1 is equal to 52 degree. We know that theta 1 is equal to 52 degree. Adjacent is equal to 186 centimeter plus 7.5 centimeter. So adjacent is equal to 193.5 centimeter. Okay. We'll parallelly consider the case 2 also. So in case 2, the theta 2 value was 19 degree, and the adjacent remains the same. It's nothing but 193.5 centimeter. Okay. So now using the tan theta formula, tan theta 1 is equal to opposite 1 divided by adjacent. Okay. So tan theta 1 is nothing but 52 degree is equal to opposite 1 divided by adjacent 193.5 centimeter. So opposite 1, which is nothing but h1, is equal to tan 52 degree into 193.5 centimeter. So we'll find h1 now. Okay. So similarly, let's find for case 2. So in case 2, tan theta 2 is equal to opposite 2 by adjacent tan theta 2. Theta 2 is nothing but 19 degree is equal to opposite 2 by adjacent 193.5 centimeter. We'll multiply tan 19 into 193.5 centimeter to find the height 2. So opposite 2, which is nothing but h2, is equal to tan 19 degree into 193.5 centimeter. Okay. So h2 is equal to, so to calculate the tan value, trigonometrical value, we can use our calculator, and okay, we can use the calculator and determine the theta value, tan theta value. Okay. For that we will choose tan into whatever the value it is. That's 52. Tan into 52 is nothing but
equal to bracket equal to
1.279. Okay. So 1.279 is nothing but 1.28 into 193.5 centimeter. So h1 is equal to into 193.5. So the height h1 in centimeter is nothing but 247.67 centimeter by rounding it off. Okay. So now similarly, let's find h2. So to find h2, similarly I'll calculate tan value first. Tan into 19 degree is equal to 0.344 into 193.5 centimeter. So h2 is equal to into 193.5, nothing but 66.63 centimeter. Okay, so the total height of the gate. So considering the equation 1, considering equation 1, height is equal to h1 plus h2, so nothing but h is equal to 247.67 centimeter plus 56.63 centimeter. Okay, 247.67 plus 66.63. The height of the gate is 314.3 centimeter. Now let's verify whether the total height of the gate is equal to the height which we got theoretically. So the height is 308 centimeter. So now let's check the percentage error in both the methods. Okay. So in first method, so method 1 was using the height formula, right? So the actual height of the gate was actual height of the gate was 308 centimeter when we measured using the meter. Okay, so using method 1, we got the height as 316.24 centimeters. So to find the percentage error, the formula that we'll be using is 316.24 minus 308 divided by 308 into 100. Okay, so method 1 value minus the actual height of the gate divided by the actual height into 100 will be our percentage error calculation formula. So now let's do this calculation in calculator and check what's the percentage error. Okay, so I'll put this in brackets. 316.24 minus 308 divided by 308 into 100. So the percentage error that we got using the height formula was 2.67%. Okay, now we'll also find out the percentage error when we did using the method 2. Okay. So method 2, using basic trigonometric functions. Okay, so these are nothing but the sine, cos, tan, theta formulas. Okay, so actual height was 308. So using method 2, the height was using this formula, we got the height to be 314.3 centimeter. Okay, now let's put this the same formula and find the percentage error in the device. So percentage error will be equal to 314.3 minus 308 divided by 308 into 100. So only thing that will be changing here is three 114.3 minus 308 divided by 308 into 100. So the percentage error is 202.04%. So we are getting the value more accurately in method 2. So if you have any other methods to calculate the height, so you can try using those methods and find the best way of solving the problem to determine the height. Okay, so here we can consider this method 2 being more accurate and efficient when compared to method 1. Thank you.
చూసారు కదా how to calculate the height of the ball or any object by using measure. సో ఎంజాయ్ చేసిన అనుకుంటున్న సెక్షన్ మళ్ళీ పరిసరికొత్త సెక్షన్తో మళ్ళీ నెక్స్ట్ వీక్ వెళ్తాం. థ్యాంక్ యూ.